Good morning. So today we're going to talk about function composition. Composition of functions may be simplest terms that we could say it's the combining the action or rules of two functions. So if we are going to compose functions, we are looking at two different functions and we're going to put them together. So a basic idea. We have a circular garden with a radius of 15 feet. It's to be covered with topsoil at a cost of $1.25 per square foot of garden space. We want to determine the area of this garden to the nearest square foot. So because it's a circular garden, we need to use our area of a circle formula, which would be pi r squared. And we know the radius is 15 feet. So I'm going to replace that r with 15. And if we simplify this, if I kept this in terms of pi or exact area, I could say that's 225 pi. Doesn't really help too much though when you're doing actual gardening and calculations. So if we were to simplify and round, this is going to give us somewhere around 707 feet squared. So that's the total area that we have for this garden. Now, using our answer that we just found, we're going to calculate the cost of covering the garden with topsoil. So knowing that the area was 707 feet, I know that the cost of topsoil is $1.25 per square foot. At this time, we're going to multiply this by $1.25, and our total cost then is $883.75. So that's an example of how I would have to combine the action of two different functions in order to get a final answer. I had to find the area first. Then using that area function, I'm going to calculate the cost by using that $1.25 per square foot. So combining two functions. Okay, so looking at this, if we have our input of x, all right, it goes into our f function, our first function. In that example, it was our area. The output that we got, which was our square footage, becomes the input that we put into g. The g function was kind of like our calculation for cost function. And that gave us our final answer of how much it was going to cost to cover the garden. Okay, we're going to try this and we're going to see that there's two different notations that we're going to be using. And we have to be comfortable and familiar with both of these notations. So when given the two functions, so we have our first function, this is what our f function will always represent in this exercise 2. And here's what our g function is going to represent. We have to find the values for each of the following. So the one thing that we need to get used to with our composition of functions is you always want to think you're going to be working inside out. So in other words, when I'm looking at this notation, I am only going to be focusing in for right now on g of 1. That means I'm going to go to the g function. And in this g function, wherever there's an x, I'm going to replace it with a 1. So I have 2 times 1 plus 3. Okay, and if we simplify this down, 2 times 1 is 2, plus 3 we get 5. So now I know g of 1 is equal to 5. If I go back now into this function, into this notation, I could substitute in place of g of 1 that value of 5 that we found. So now I'm going to take that function, the f function, and anywhere I see an x, I'm going to plug in 5. Okay, so I have 5 squared minus 5. So 5 squared is 25 minus 5, I would have a total of 20. So I know my f function, when evaluated by figuring out what the g function is at 1, will give me a final answer of 20. Okay, so again, always think inside out. First thing that we're going to do here is evaluate the f function at 2. So I go to the f function, anywhere I see an x, I make it a 2. And we're going to simplify. So 2 squared, I get 4, and 4 minus 5, we get a negative 1. So to begin, we know the f function at 2 is a negative 1. Now I'm going to go to the g function. So keep in mind what the notation is saying, g of f of 2. Okay, well, we know f of 2 is negative 1. I'm going to plug that in. So it's saying evaluate the g function at negative 1. So anywhere I see an x, I make it a -1. So 2 times -1, we have a -2, and a -2 plus 3, I'm going to get a final answer of 1. So in the end, when I find my final answer, I can say that g of f of 2 is a value of, okay? Same idea, same notation, but notice we have g of g. So all that means is we're using our g function, but twice. So again, first thing I want to do is evaluate the g function at 0. So I take 0, I plug it in. 0 times 2 is 0 plus 3, I get a 3. So the g of 0 is equal to 3. Now I have to go back and plug that 3 in to the g function again. It's just this time evaluating the g function at 3. So I have 2 times 3 plus 3. So 2 times 3, we get 6. Plus 3, we get a total of 9. Oops, not g, that was 9. So I have the g of 0 gives us 9. So that's one notation. Another notation using the same functions is we get this open circle. You've seen this in geometry. You get this open circle, and it's the same idea. This notation would really be the same thing as saying this. They mean the same. Different way to write it. You're going to work from right to left or inside out. This notation, it may be easier to think right to left. That's what you would have done in geometry, is work right to left on these compositions. Okay, so first thing we're going to do is the g of -2. And so we're going to plug in anywhere I see an x, I make it a -2 plus 3. So 2 times -2, I get -4 plus 3, we get a -1. So we'll take this answer and plug it into the f function. So in our f function now, I have -1 squared minus 5. So -1 squared, I get 1. 1 minus 5, I'm going to have a -4. So final answer for this, I could say the f of g of -2 is equal to -4. Working right to left. So again, I'm going to start with that f function evaluated at 3. So I have 3 squared minus 5. So 3 squared is 9 minus 5, we get 4. I'm going to go now into the g function, and anywhere I see an x, we're going to make it a 4 using that answer that we just found. So in the g function, I have 2 times 4 plus 3, so that's 8 plus 3, and that gives us a total of 11. So I can say the g of f of 3 is equal to 11. And now, just like we saw in that first notation, we can still use just one function in our composition. So we have the f of -1. So again, starting with our f function, I'm going to plug in -1. Be careful when you're squaring. So I have a -1 squared is a positive 1, minus 5. So 1 minus 5, I have a -4. So now I have to go back into the f function and reevaluate it, but this time at -4. So I have -4 squared minus 5, so -4 squared, I get a total of 16, and 16 minus 5, I have 11. So the f of f evaluated at -1, final answer, we get 11. Okay. You can also take a look at this on graphs. Same idea with graphs. It's going to be evaluating it the same way. So like you can see from these first two notations, I have to work inside out, but I have to be careful the graph I'm looking at. So we're going to start here. So it's saying the f of 2. So here's my f graph on the left. And that is saying to you when x is 2, what am I going to get for a value? So if I go over here to the graph, I see here's 2. When I read up, I get a value of 3. So I could say f of 2 is equal to 3. So now I have to go to the outer function, which is our g function, and evaluate the g at 3. So I go to the right graph, go to g, go over to x, 1, 2, 3. I go up 1, 2, 3, and I find my answer here is 3. So the g of f of 2, final answer 3. Okay, second one, f of g of negative 1. So again, working inside out, starting with the g function, evaluating that at negative 1. So I go to the g function, I go negative 1, which means I have to read down to get my final answer. Final answer down here is negative 5. And now I go back into the f function. So now I have to go to the left function, and I need it to figure out when my x value is negative 5. So I have to go 1, 2, 3, 4, 5. What is my y value going to be? So I have to read down, and it looks like my y value is going to be a negative 1/2. Okay. Letter C, evaluating it only at one graph. So I start by saying the g of 1. So when x is 1, I get an answer of 3. So the g of 1 gives you 3. Now I'm going to take that again, and I'm going to evaluate the g of 3. So same graph, g of 3. So this time I have to count over 1, 2, 3. I count up 1, 2, 3. So our final answer here is 3. Okay. I'm going to let you try these next 3, keeping in mind if you were to evaluate this, you're going to evaluate the right first, and then you're going to go to the left. I will give you these 3 you can try. Final answers I have on letter D would be an answer of 3. On E, I have an answer of 2. And on F, I have an answer of 3. So that gives you 3 that you can practice and see how you do. Okay, so a little different here because now we have, again, the same functions. It's just this time I don't have any numbers that I'm plugging in. I'm actually going to keep things in terms of x. Works the same way. So this is saying I need to take the g function and plug it into the f function. So in my f function, anywhere I see an x, I'm replacing it with this entire value of the g function. So I'll be replacing it with 5x plus 4. Okay, so I'm going to go to the f function. I'm going to rewrite the f function. Anywhere I see an x, which would be right here, I'm going to replace that whole thing with 5x plus 4. Okay. Don't forget, you have a minus 2. So this, if I'm looking at my f function, here's my 3x minus 2. So all I did was replace the x with that g function. Now we need to simplify. So we're going to distribute through. This would get me 15x plus 12. And then I have the minus 2. So final answer here, I'd have 15x plus 10. So that would be evaluating the f function by plugging the g function into it. Okay, try our next one. Next one is just going backwards. So this is saying in the g function, anywhere I see an x, I'm going to replace it with the f function. So I'm going to plug in 3x minus 2. Okay, so in my g function, I have the function is 5x plus 4. So I have 5. I'm going to replace the x with 3x minus 2, and then I'm going to add on 4. So if we expand this out, I have 15x minus 10 plus 4. And then to simplify, combining our constants, we're going to have 15x minus 6. So here is our g function evaluated with the f function plugged into it. Okay, we have one more to try. So, same thing. We're going to find the f of g of x. So I'm going to start with my f function. And in the f function, anywhere I see an x, I'm going to plug in the g function, x minus 5. So I know my f function is just plain old x squared, which means I'm going to plug in x minus 5 and square it. So keep in mind what we have here, x squared. I just replace that with the g function. Okay, so be careful with this. This is an easy place for people to make mistakes. If I'm squaring something, I need to think I have that factor twice. So this allows you to solve this by either using double distribution, FOIL, the box method. I'm going to do a little bit of the double distribution. So I would have x squared, my outside terms, so x times -5, I get -5x. My inside terms, -5 times x, again, is another -5x. And then my last terms, -5 times -5, is a positive 25. So if we simplify this up, I have x squared minus 10x plus 25, and that would give me my final answer for the f of g of x. Okay. Please bring any questions that you have to class. We will go over this together. Have a great day.